Alright, here we go, guys. Try to make this quick, so let's just dive right in. This is our projectile problems worksheets, mainly just dealing with the horizontal direction for the first part of this. So we'll answer the top question. To solve projectile problems, you must divide up your information into two parts. The first part is going to be our x direction, which has horizontal motion. Okay, and then our y direction, which has our vertical motion. Okay, and the equations that we're going to use for each type, we're going to want to use our distance horizontal is equal to our velocity initial horizontal times our time, and we're also going to want to use our distance in the vertical equals velocity initial in the vertical times time plus 1/2 at squared. Those are going to be the two equations that we're used. Okay, let's move on to part 1. Okay, a ball rolls off a 1 meter high table and lands on the floor 3 meters away from the table. We want to answer A, how long the ball was in the air for. B, what was the horizontal velocity, or with what horizontal velocity did the ball roll off the table. Let's go ahead and let's skip C, so I'm just going to cross C off. Okay, and then D, what is the horizontal velocity of the ball just before it hits the ground. So let's do ourselves a favor and let's draw a little picture here. Okay, here I have my ball, and it's going to roll horizontally, and it's going to land 3 meters away from the table, and it's also a 1 meter tall table. Okay, so I want to figure out the time first off that it takes. Okay, because this is a horizontal equation, we can assume that when it comes off the table, it has only horizontal velocity. It doesn't have any vertical velocity. Therefore, in my equation for the distance in the vertical, this first part is just going to go away. It's going to go to 0 because I don't have any initial vertical velocity. So when I go to calculate this, I'll say distance in the vertical is equal to 1/2 my acceleration times time squared. And now we can plug in answers to solve for this, or plug in our values to solve this equation. We also should hopefully know that I can rewrite this equation to solve for time, and when I do that, I get time equals 2 times my distance in the vertical over my acceleration. So my time is going to be the square root of 2 times 1 meter is my vertical distance over 9.8 meters per second. You're going to have to excuse me real quick while I grab a calculator. Let's see. Okay, so I have 2 times 1 is just 2 divided by 9.8. And remember, we don't want to put this as a negative, because if we put it as a negative and we take the square root of it, it's going to be the square root of a negative number, which we know is imaginary. So when I take the square root of this answer, I get that the time to roll off the table took 0.45 seconds. So that's part A. 0.45 seconds. Okay, part B. With what horizontal velocity did the ball roll off the table? Okay, we're dealing with horizontal, so we're going to look at my horizontal equation. So it's going to be my distance horizontal equals my velocity initial horizontal times my time. I can plug in my time that I calculated from my vertical direction into my horizontal direction, because the time that it takes doesn't matter whether we're dealing with horizontal or vertical. So I can just plug that straight in. So I want to rewrite this equation to solve for my vertical or my horizontal velocity. So when I do that, it's going to be initial horizontal velocity is equal to horizontal distance over time. And when I plug in values for that, my horizontal distance is 3 meters divided by my time is 0.45 seconds. And when I do that, 3 divided by 0.45 gets me 6.67 meters per second. And that's going to be the answer for part B. Okay. Now, part D, what is the horizontal velocity of the ball just before it hits the floor? So through going through our notes and through talking about this in class, we should know that at each point on this curve, my horizontal velocity should be the exact same. So if at every point on this curve my horizontal velocity is constant, then that means that part D is also going to be this answer. So this answer is for part B and part D. Okay. So moving on. A carpenter tosses a shingle off a 9.4 meter high roof, giving it an initial horizontal velocity of 7.2 meters per second. Find what the final vertical velocity of the ball will be. Okay. First off, we're not even dealing with a ball, so that question's kind of a little weird. And again, just like we crossed off the one before, well, let's just go ahead and cross this one off too, because that one's kind of not something that I would ask you or that we're going to deal with. So then our questions are, how long, which is our time, and how far does it move horizontally in this time? So we're going to look for our distance in the h equals question mark and time equals question mark. Okay, so again, I just like to write out my equations so I can see them. Equals equals velocity horizontal times time, and my vertical distance. Again, we're dealing with no initial vertical, so I'm just going to write this out as 1/2 at squared. Okay, so I'm given a vertical distance here. When it says height, it's going to be talking about the vertical direction. So I know that. I know my acceleration, so I can solve for my time. And again, we just rewrite this equation. This equation to solve for time is the square root of 2 dv over a. When I plug stuff in, I get the square root of 2 times 9.4 meters divided by positive 9.8. And when I do that, and that's meters per second squared. Oops. Per second squared, which should leave me with seconds. And I'll do this 2 times 9.4 divided by 9.8. Take the square root of that answer. And the time that I get is 1.38 seconds. So that's going to be the time that it takes for this shingle to remain in the air until it hits the ground. Now I want to solve for how far, so I'm going to look for the horizontal distance. So now I'm going to look for this equation, and I don't need to rewrite anything because it's already written to solve for my horizontal distance. So my horizontal initial velocity is 7.2 meters per second times my time is that 1.38 seconds. So when I do 7.2 times 1.38, I get 9.97, and we can just round that to 10 meters. So in 1.38 seconds, this shingle will fly 10 meters away from the base of the building that the carpenter is tossing this shingle off of. Okay, number 3. A tiger leaps horizontally from a 12-meter high rock with a speed of 4.5 meters. How far from the base of the rock will she land? Okay, so again, here's my equations. No initial vertical velocity, so I'll just leave that off. We have a 12 meter high, so that's our dv with an initial VIH of 4.5, and we want to know DH. Okay, so I don't know my time, so I can't use this first equation just yet, but I know I'm going to need to solve for DH. So we're going to start by plugging this in to solve for time. Again, just off the bat, we should know to rewrite for time, it's 2 times dv over a. So my distance in the vertical is 12, my acceleration is 9.8, so I should have 24 divided by 9.8, take the square root of that, and I will get time equals 1.56 seconds. And I'll take that answer and I'll plug it into this equation now, and I can use that to solve for my distance horizontal. So DH equals my V initial in the horizontal, which is 4.5 meters per second, times my time, which is 1.56 seconds. And when I do that, I get that my distance in the horizontal that this tiger leaps is, rounding down, 7 meters. So this tiger will jump 7 meters from the base. Okay, a diver running 1.6 meters per second dives out horizontally from the edge of a vertical cliff and reaches the water 3 seconds later. We want to know how high the cliff was and how far from its base did the diver hit. So this one's a two-parter. Okay, we're gonna have, right now we know our VIH, or initial horizontal, and we know our time. Okay, so given my two equations, we know we can solve for our distance in the horizontal right off the bat because we're given two of our three variables. So I'm just going to write it out. DH equals my V horizontal initial, which is 1.6 meters per second, times my time, which is 3 seconds. So my distance in the horizontal is going to equal 4.8 meters. So that's how far away the diver lands away from the base. Now I can take that answer and I can plug it into my second equation, which is going to be that one, and I can solve for my vertical distance. Again, this one's convenient because we don't have to rewrite our equation. Again, no initial vertical velocity, so it's going to be 1/2 my acceleration, which is -9.8, and my time is 3 seconds, sorry. 3 seconds, and we need to remember that we need to square that. So when we do that, 3 squared is 9 times -9.8 times 1/2 gets me, it's going to give me a -44 meters tall. We should know that because we're talking about vectors and we're talking about displacement, when I talk about a negative, here's my cliff, here's my reference point. So the whole reason that's negative is because the direction that I'm measuring this in is down 44 meters. But you can also tell me that the cliff is just 44 meters tall. That would be also an acceptable answer. So on the test, I'll take either of those answers. Okay. The next one, and I'm gonna, I guess we'll just continue. It's a lot to keep writing the equations over and over on the side. So hopefully by now you know them. If not, I'm gonna write them as I do the problem. So hopefully you're getting familiar with them. Okay, you toss an apple horizontally at 9.5 meters per second from a height of 1.8 meters. Simultaneously, you drop a peach from the same height. How long does it take the peach to reach the ground? Okay, so we did this one in class. So as this one's missing a little bit of information, we should also make sure that we assume, that's a U, assume no air resistance. If we don't have any air resistance, what we learned in Unit 1, what Galileo taught us, is that everything falls at the same rate. Okay, no matter how heavy it is, if we neglect air resistance, everything will fall at the exact same time, in the exact same rate. Okay, so it doesn't matter if I'm talking about a peach that I drop straight down or an apple that I toss out horizontally with any velocity, whether it's, you know, 1,000,000 meters per second, which would be ridiculous, but it doesn't matter. However fast that is, they'll land at exactly the same time because they're falling at the same rate of negative 9.8 meters per second squared, which is the force of gravity, or the acceleration due to gravity. So in order to calculate this, okay, I can basically just use my equation to solve for time, where time equals the square root of 2 dv, which is 1.8 meters, divided by my acceleration, which is 9.8, and I can take 2 times 1.8 divided by 9.8, take the square root of that, and when I do that, I get my time equals 0.61 seconds with a little bit of rounding. And again, that doesn't matter if I'm throwing an apple out off a cliff. If I throw this apple out and it lands over here, it'd be the same as if I just drop a peach straight down and it lands at the same height. As long as I'm dropping them from the same height, they're both affected by the same acceleration due to gravity downward, which means that they're going to hit at the exact same time. Okay, number 6, an arrow fired horizontally at 41 meters per second travels 23 meters horizontally before it hits the ground. From what height was it fired? So we want to solve for our distance and our vertical. So we're given our DH and we're given our VIH, or velocity initial on the horizontal. So right off the bat, you should be saying, okay, well, I have those two. That means that I can solve for time using this equation. VIH times time. Okay. Solving for time, rewriting this equation, I get time equals my distance in the horizontal divided by my velocity in the horizontal. So when I do that, time equals 20, let me erase that. One more. Equals 23 meters divided by 41 meters per second, which will leave me with seconds. And when I do that, the time that I get is 0.56 seconds. 0.56 seconds. So that's the time that it takes for this arrow, which is fired horizontally, to hit the ground. Now, knowing that, now I can plug that into my other equation and I can solve for my distance in the vertical. My distance in the vertical equals 1/2 my acceleration, which is negative 9.8 meters per second squared, times time, 0.56 seconds, and don't forget to square it. Okay, when I take that and I square it, I get 0.3 times negative 9.8 times 0.5, and the vertical distance that I get, or the height that this was fired from, is negative 1.5 meters, which again is just our reference. Okay, and if I think of 1.5 meters, that's roughly the size of the average person's chest height. So if I'm looking at somebody firing an arrow, let's see if I can draw this. Okay, here's a bow and arrow. Okay, terrible drawing. So that's, again, it's going to be in reference from this height downward, which is why we have that negative. So this is 1.5 meters in height, or negative 1.5 meters total. Okay, let me can keep consistent with our theme and circle that in purple. The last equation we have: a ball is thrown horizontally from the roof of a building 50 meters tall and lands 45 meters from the base. What is the ball's initial speed? Again, we did this one in class, so you guys should hopefully know how to do it, but let's go through it real quick again. So, building of 50 meters tall, that's going to be our DV. Lands 45 meters away, that's going to be our DH. And we want to know the ball's initial speed, which is going to be our VI in the horizontal. Okay, the first thing I know, if I'm looking at these equations and I have them written down, VIH times time and distance in the vertical equals 1/2 AT squared. If I look at this first equation, okay, I know my horizontal distance, but I don't know my initial speed and I don't know my time. So I'm not going to be able to use that first equation. If I look at this second equation, I do know my vertical distance, I do know my acceleration, so I can solve for my time. So we're going to use that, and again, just like all the other ones, we're going to use our derived time equation that comes from this equation, which is 2 times distance in the vertical, which in this case is 50 meters, divided by my acceleration, which is 9.8. And when I do that, I get 2 times 50, which is 100. And then I divide that by 9.8, gets me 10.2. And I take the square root of that, and I get time equals 3.2 seconds. So that's going to be the time that it takes for this ball to hit the ground. And now that I know that time, again, vertical time and horizontal time are the same, so I can just plug it in that equation and I should be able to solve for my initial velocity once I rewrite this equation. So I'm going to take this equation, I'm going to rewrite it to solve for initial horizontal velocity, and when I do that I get initial horizontal velocity equals horizontal distance divided by time, and when I plug in my given variables for these, I get 45 meters divided by this 3.2 seconds, and 45 divided by 3.2 equals velocity initial in the horizontal equals 14.1 meters per second. So if you want to throw a ball off something that's 50 meters tall and you want it to hit a target that's 45 meters away, you're going to have to throw it with an initial velocity in the horizontal direction of 14.1 meters per second. Alright, so we ran through those quick. Hopefully you stayed caught up. If you need to, slow the video down, rewatch some parts. This should be kind of a review from doing our bullseye lab, and hopefully we've had lots of practice up to this point. And you guys, if you have any questions, don't be afraid to come and stop by a classroom before or after school to get some help. So, alright, thanks for watching. We'll see you in the next video.